ingredient. Analytical method is known to be validated, is being evaluated through characteristics such as accuracy, precision, specificity, limit of detection and limit of qualification and robustness.
The characteristics of analytical method should be within prescribed limit and define standards to confirm its accuracy and authenticity.
Characteristics for validation of an analytical method are highly dependent on the understanding of statistical terms and the concept of spiking of analyte to be used in your method. Spiking is used in such circumstances where amount of analyte is very low in the solution to be injected in HPLC because the peak obtained in the chromatogram may be too much small, which cannot give accurate.
يعني هون النتائج هي بي، النتائج الطبيعية هي بي، لكن لاحظوا البيك اللي طلعت للمادة تبعتنا كتير صغيرة، كتير صغيرة، فهون نعمل سبايكينج بأننا بنحقن من المادة أو مع المادة مواد تانية، ونفس المادة بنحقن منها بزيادة عشان تعطينا بيك قوية ونعرف بالضبط التركيز تبعها. بس النتائج هاي أسهل إني أنا أعرضها من النتائج اللي زي هاي. هذا اللي بنسميه السبايكينج.
Reading as desired. The diagram named B on your screen is representing the natural peak of the analyte before spiking, whereas diagram A is representing the sample after addition of known amount of analyte in the testing sample. Average, standard deviation and relative standard deviations are statistical terms to calculate the closeness in the data. These terms are used to measure the characteristics of validation such as accuracy and precision.
يعني الاكيورسي والبريسيجن لما بيجوا يحكوا عنهم بياخدوا الستاندرد ديفيشن. هون بده يحكي لنا بس كلمتين عن الستاندرد ديفيشن كيف بيحسبوه، الانحراف المعياري.
The formula required to calculate average, standard deviation and relative standard deviation are shown on the screen. We should have basic concept of these terms to understand the validation process of analytical method.
The term accuracy in validation is used to observe the closeness of the results obtained from analyte compared with a reference standard. Accuracy is directly related to linearity, which follows the concept of Beer's law.
Beer's law apply in liquid chromatography, as absorption of light in the analyte is directly proportional to the amount or concentration of analyte in the sample solution. We measure the accuracy of an analytical method by measuring the absorption reading of the analyte at different concentration. The diagram shown on your screen is best example of linearity relationship between concentration of analyte in the solution and absorption of UV light. In concept of linearity with respect to Beer law, at a specific wavelength the absorption of light in the known amount analyte should be constant. To check accuracy of an analytical method, we do spiking of analyte in sample by addition of known amount of analyte in the sample and compare its absorption value obtained with the true value. Let's suppose that an analyte sample of known concentration of 80% given UV absorption of 340. So if we increase sample concentration from 80% to 100%, then UV absorption should increase near at about 420, in a linear range as shown in the diagram. If you succeed to obtain a linear graph with respect to concentration of analyte and UV absorption, then your analytical method is acceptable and a validated method in terms of accuracy. In case the analyte in the sample at different concentration, UV absorption reading which do not give linear graph as shown on your screen, then it means your method is not correct, and you need to change the method.
لازم نغير الطريقة.
If you study ICH document regarding validation, then it recommends to perform accuracy studies on a triplicate replicate of different concentration and 9 determination. The reason is to easily calculate mean value, standard deviation and relative standard deviation. The next characteristic of validation after accuracy is precision, the analytical method precision. It also confirms the consistency and uniformity of the analytical method in different situations and in different environments. The component of precision, mentioned on the screen, are a key toward achieving validation of the analytical method, because these three components ensure the accuracy of the method from very start of the method development, towards its application in different laboratories. Repeatability is analyzed or determined by relative standard deviation of the peak areas of chromatogram, obtained in the same laboratory by the same operator, same machine, and same sample. Relative standard deviation should not be more than 1% for the minimum of 5 injections. If relative standard deviation values stay within the prescribed limit, then your method is validated and accurate to be used. Precision is best when we want to choose a UV spectrophotometry method instead of HPLC. This is because we compare the results of UV with HPLC and consider a method validated if its relative standard deviation stays within limits. Please have a look on the screen for the table where a comparison of successful precision concept is shown
Day
among
1, Day 2,
HPLC and
Day
UV
3.
analytical method. The limits of relative standard deviation vary from analysis to analysis, especially in case of impurities study profile. Intermediate precision is the next step, after confirming the uniformity and accuracy of the analytical result during method development. When an analytical method is fully developed, then its accuracy is to be checked at different laboratory, with different operators. The objective is to ensure that the method will provide the same results when similar samples are analyzed, once the method development phase is over. The reproducibility is to confirm that analytical method develop is applicable in different laboratories at different environment. It also helped to issue precautionary measures if an analytical method required temperature control or pH variations. Limit of detection and limit of qualification are parameters to check UV absorption response of the analyte at a minimum level from where it gives you a constant and authentic reading to move forward in selection of analytical method. When we observe the peak in the chromatogram, it actually represents the amount of the light passed through analyte after separation from other ingredients at a specific wavelength, which is being captured by the UV detector and changed into a peak by the data system. Limit of detection and quantitation actually depends upon detector sensitivity and detector noise profile, because it influences the baseline of the data system, on which peak is to be generated. The minimum quantity of the analyte should generate peak parallel to the baseline. If we look on the diagram of your screen, it shows that peak can be detected when it is 2 to 3 times of the baseline noise level, because from this point peak is clearly emerging on the attenuation scale of the data system, and one can clearly differentiate the peak from baseline. Quantitation limit is the parameter at which the peak obtained on the data system can be determinant of the accuracy and precision characteristics of the validation. In short, we can say that the amount of analyte UV absorption is a constant value in terms of relative standard deviation. Specificity is the characteristic of validation method in which we actually check the peak-to-peak difference in retention time in the same sample. We also check the analyte with respect to other impurities present in the sample. Suppose your analyte retention time is 3 minutes in the chromatogram, so you add an impurity in the sample and check either it's give separate peak on the data system at different retention time than your analyte, or the peak is mixing with your analyte. If the impurity peak is separated from your analyte peak, then your method is validated. The specificity test is basically required during phase 3 trials of product to check any degradation product mixing with the peak of your analyte. If the impurity peak is mixing from your analyte peak, then your method is not validated. If it happens during stress testing, then it proves that your analytical method will not be applicable in post-marketing when a product will face harsh environment condition. The peak mixing may also happen due to column H, impurities present in column and pH of the mobile phase. Therefore, system suitability should be checked before starting validation method. Therefore, system suitability should be confirmed with respect to the parameters shown on your screen with their acceptable limits. When a method got validated with respect to accuracy, linearity and specificity, then the authenticity of the method is checked on other laboratories, or by changing the parameters of the method, such as minor changing concentrations in mobile phase, wavelength and flow rate of the method. Sample solution stability is also one of the important parameter for method validation, because mostly, validation method required 24 hours or long time period for getting full results on HPLC, and during this period, your analyte solution shall remain stable.